Do you enjoy cooking? If so, you know it is very important to add the right type and quantity of ingredients to get your desired food item. If you forget to add one key ingredient, you could mess up the entire recipe. For example, one time when I was making cookies, I totally forgot to add eggs and the cookies tasted horrible. Elements are just like the ingredients used in cooking, and the type and quantity is crucial to getting your desired result. Molecular formulas are like a step-by-step recipe that tells information about what is involved in making a certain molecule. Molecular formulas express what a molecule is comprised of by identifying the type of elements involved and quantity of atoms present. Remember, a molecule is comprised of at least two atoms joined together. A molecular formula includes the chemical symbols of elements involved in a molecule and a subscript to indicate the quantity of atoms of each element. If you are like me, one of your favorite things to do is breathe, right? Did you know that the air you breathe has the molecular formula O2? The subscript 2 indicates there are two oxygen atoms present in this molecule. What do you think would happen if we added one more oxygen atom? Would we still get an oxygen molecule? The addition of one more oxygen atom could totally change the result. Just like in cooking, if you change the quantity of ingredients, you get something completely different. If you combine three oxygen atoms, you would not get an oxygen molecule. You would get ozone. Ozone is very different than an oxygen molecule. It provides a protective layer over Earth that shields the sun's dangerous rays. The molecular formula for ozone is O3. The subscript of 3 identifies that there are 3 oxygen atoms involved in the formation of this molecule. Has all of this talking about molecular formulas made you thirsty? Perhaps for a beverage like soda? Have you ever wondered what ingredients make up soda? The recipe for soda has many ingredients, such as sugar, caffeine, and water. Sugar is also known as glucose. The molecular formula of glucose is C6H12O6. The formula identifies there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms present. Another ingredient in soda is caffeine, which has the molecular formula C8H10N4O2. This molecular formula identifies there are 8 carbon atoms, 10 hydrogen atoms, 4 nitrogen atoms, and 2 oxygen atoms. Lastly, soda also contains water, which has the molecular formula H2O. This formula identifies there are 2 hydrogen atoms and 1 oxygen atom present. Did you notice there is no subscript on the oxygen atom? If an atom does not have a subscript, it is implied to be 1. Sometimes a molecular formula has a numerical coefficient in front of the entire molecule. For example, if a molecular formula is written as 2H2O, the numerical coefficient of 2 means there are 2 water molecules present, with each water molecule having 2 hydrogen atoms and 1 oxygen atom. To determine the quantity of atoms involved in this molecule, simply multiply the coefficient by the subscript of each atom. To find the total quantity of hydrogen, multiply the numerical coefficient of 2 by the subscript of 2. This quick calculation reveals that 4 hydrogen atoms are present, because 2 multiplied by 2 equals 4. Then to find the total quantity of oxygen atoms present, multiply the numerical coefficient of 2 by the subscript of oxygen. Since there is no subscript of oxygen, remember it is implied to be 1. So the calculation is 2 multiplied by 1, which equals 2. This calculation reveals there are 2 oxygen atoms present. Sometimes the atoms that make up a molecular formula are ions. Remember, an ion is an atom that carries a charge because it lost or gained 1 or more electrons. Recall there are 2 types of ions, a cation and anion. An anion is a type of ion with an overall negative charge because it gained 1 or more electrons. And a cation is a type of ion with an overall positive charge because it lost 1 or more electrons. Lastly, recall when an anion and cation form a bond, it is called an ionic compound. Molecular formulas are also written for ionic compounds. For example, the ionic compound sodium chloride has the molecular formula NaCl. The atoms involved in this compound are ions. Sodium is a cation and chloride is an anion. To write the formula of an ionic compound, remember this general rule. The subscript of the cation is the same number as the charge of the anion. And the subscript of the anion is the same as the charge of the cation. Please note, though, that the subscripts never have a positive or negative sign written with it. Let's look at an example of using this general rule to write the formula of an ionic compound called magnesium nitride. The charge of the magnesium cation is positive 2, and the charge of the anion nitrogen is negative 3. To write the formula for this ionic compound, the general rule states that the subscript of the anion will be the charge of the cation. The charge of the cation magnesium is positive 2, so the subscript of the nitrogen anion is 2. Now let's find the subscript of the cation. The subscript of the cation magnesium will be the charge of the anion. I know that the charge of the anion is negative 3. So the subscript of the cation magnesium is 3. Putting all of this together, the formula of the ionic compound magnesium nitride will be written as Mg3N2. The cation will always be written first in a molecular formula. Let's look at another example of an ionic compound called potassium chloride. This ionic compound is comprised of a cation potassium with a positive 1 charge and an anion chloride with a negative 1 charge. To write the formula for potassium chloride, the subscript of the cation will be the same as the charge of the anion. Since the charge of the anion chloride is negative 1, the subscript of potassium will be 1. Now let's find the subscript of the anion. The subscript of the anion will be the same as the charge of the cation. The potassium cation has a positive 1 charge, so the subscript of chloride is 1. Putting this all together, the formula for the ionic compound will be KCl. As you can see, the K and Cl both have a subscript of 1. When an atom has a subscript of 1, you can just leave it off. So the simplified formula for potassium chloride is KCl. Even though KCl do not have any subscripts, it is implied that there is 1 potassium atom and 1 chloride atom. In this lesson, you learned that molecular formulas are like recipes that describe the type and quantity of ingredients that make up a certain molecule. Molecular formulas express what a molecule is comprised of by identifying the type of elements involved and quantity of atoms present. For example, the molecular formula of water is H2O. This formula identifies there are 2 hydrogen atoms and 1 oxygen atom present. Sometimes the atoms that make up a molecular formula are ions. Remember, an ion is an atom that carries a charge because it lost or gained 1 or more electrons. When writing the formula of an ionic compound, remember this general rule. The subscript of the cation is the same as the charge of the anion, and the subscript of the anion is the same as the charge of the cation. For example, an ionic compound called magnesium nitride has a magnesium cation with a positive 2 charge and a nitrogen anion with a negative 3 charge. To write this as a molecular formula, the magnesium cation will have a subscript of 3, which is the charge of the anion nitrogen, and the nitrogen anion will have a subscript of 2, which is the charge of the cation magnesium. Putting this together, the molecular formula of magnesium nitride is Mg3N2.